Okay, good evening, everyone. Once again, this is Teacher Joseph. I welcome you all from a math lesson. Right now, we are having a physics lesson, but I said as you come in, please mute your mic.
Yes, teacher.
Yes, do that. As you come in, you mute your mic. But as we start this lesson, let me request someone to pray for us. Anyone ready? You put up your hand and then you pray for us. Karen, I see your hand. Yes, pray for us, please.
Time.
Humble ourselves and we pray. Heavenly Father, as we are going to start our lesson, help us, guide us in each and everything that we are going to learn. Guide us and help us to learn each and everything our teacher is going to teach us. You give us knowledge, wisdom, and understanding. We thank you for each and everything you have given us, the opportunities that you have given us to learn, and the teachers that you have given us to teach us. In the name that is above all names, the name of Jesus Christ, we have prayed.
Okay, thank you, Kellen, and I thank everyone for joining us. Okay, for now you can lower your hand. On board, I will come. The teachers on board, I see teacher Wakayana John and teacher Doreen. And for this hour, we shall move with them going forward. So for this session, we are going to look at a little bit of work done or a new topic, which is under, or basically it is work, power, and energy, but basically we shall look at work done, basically for this session. But when we resume the other lessons, we shall proceed with refraction in that sense. So for now, I want us to head, let me hope you can see my screen, Ebly. That's so?
Yes, we can see it, Teacher Joseph.
Okay. Okay. Okay, right away we shall come to this. And I request someone to read for us. Anyone ready? Pauline, we are sorry your battery is low, but we are here just for an hour. Hopefully you will get some time, or you'll be with us for some time. Teacher Doreen, do you see any hands to read for us what you have?
Yes.
Karen is very active this afternoon. Thank you, but let's have other friends as well.
Okay, I think they are still in the process of raising. Okay, we are having Tumtende Karen.
Okay.
Tumtende Karen, you can.
Senior 3 physics lesson, topic, work, power, and energy. Subtopic, work done. Concept, work done to clean different farmhouses by Teacher Joseph Chijambu, Dr. Doreen Nachibuya, and Teacher John Bakayana. Theme, skilling the youth in schools for the world of work. Entrepreneurship, our future.
Okay, thank you, Karen, for that. All right, for now, as I said, basically for this lesson, we shall look at work, the topic of work, power, and energy, but basically we shall look at work done. And our concept this evening will be, how do we do work as we clean our different farmhouses? We have looked at a number of them in the farm camp, and we want to specifically see what we really apply as we clean those houses. You might see that we are going to specifically look at poultry houses, but we shall request you to do some work, okay? considering the different houses you're having. You can be having a piggery unit, or you can have a cattle shed, okay, and many others. So specifically for this lesson, we are talking about poultry house, but we can have many other examples, and we shall task you to do work, cleaning them going forward. Okay, for now, I'll move to the next slide. Okay. Yes, another person to read for us. Yes, teacher Doreen in the chat has shared the registration link. Please take time and register. But for now, let's have someone to read for us. Let's have the gentleman as well on board. Ladies,
I don't know.
Yes.
I don't know whether Ahan is a girl or boy.
Ladies are becoming too common this evening. Let's have as well the gentlemen. Okay, maybe as gentlemen are getting set, let's have Pauline to read for us. Just reading what we have right there.
Learning outcomes. By the end of this lesson, learners should be able to define work done, apply the concept of work done to clean different farmhouses.
Okay, thank you, Pauline. Basically, these are the learning outcomes or objectives that we need basically for this lesson, and we shall define work done, and as well we shall look at some applications of where I can do work as we clean different farmhouses, but as well we shall work out some examples, and then we shall have an activity and then an exercise after, of which we shall post our work in the Padlet. Of course, we shall share the links, and then you'll be able to share. Okay, going forward, we have this. Someone ready to read for us?
Anybody?
Just reading. I will talk about the videos later. Madrid, don't just open your mic. Please put up your hand if you want to contribute. Thank you.
Can we get any other person apart from Karen? Okay, let's have Mildred. Mildred Joy.
How to clean a poultry house by Irasuviza Anita. Questions: which requirements did Anita use? Which major physical quantities relate with Anita's poultry house cleaning activities? Source full video. Simple demonstration of work done by teacher John Bakayana.
Okay, thank you, Mildred. We are going to watch this video, but I attached the links at YouTube, which links of videos we uploaded by Mr. Wakayana John. We have him as well here. So the video that I'm going to play is basically on my laptop, but when you use those links, you'll be able to access all these videos on YouTube. And after, when I share this document in the Padlet, you'll be able to access those links. So for now, I first stop sharing this, and then we come to the video itself for Anita. Then I will talk about it and then the questions. So for now, I want us to first listen in. Yes, we listen in and then we see.
Everyone, my name is Irasuiza Anita from St. Mary's College, Rosa, commonly known as Makorash, and I'm in senior 2. I want to show you my cleaning process for every 2 weeks for my poultry. So I clean using a spade, a broom, and a wheelbarrow. Though the wheelbarrow I left it because the gate is small to here and it cannot allow the wheelbarrow to pass through. So after cleaning, I take my manure in the vegetable garden, and this allows them to grow well. Yeah, as you can see. So when you're cleaning for your poultry, after cleaning, you allow the house to allow in fresh air, because now there are many diseases in here. That's why I built many of these. Not me, but I was supported by my father, and I was able to do this. So after cleaning this one, they go in another one, so that I can allow the house to allow in fresh air. And when you're putting new litter, don't put them inside immediately. When you're putting new litter, don't allow them to settle in immediately, because there is always dust, and this can make them have influenza, which is bad flu, fowl flu. Yeah. So after cleaning, I'm going to take this to my vegetable garden, and my vegetable garden is not far from here. It's like just 100, if I'm correct. They're just 100 meters. 100 meters. That's why I'm going to leave the place so open. And after putting in the litter, I will allow it for 1 day, so that the birds cannot get some fruit. Yeah. So this is how I do it. I pack the things and take them to my vegetable garden. So this is my wheelbarrow that I take in my manure up to the vegetable garden. So I was advised at least have just 1 tenant in your home. Now for us in this place, consider that a home that does not have a hen is not a home. And everybody should be having a vegetable garden, because vegetables are so vitamins. Yeah, everything. Vegetables are nice. So as you can see, it's not far away.
Michael.
So also here, not that large enough. You can see there is cabbages, beans, some red pepper, all that is in my vegetable garden. It has many things. You can see the red pepper. This is the manure I was talking about. The greens, they are here all. The view is nice. This is not all weed. There are some dodo, those still young, but we eat. The amaranthus, then green pepper, those still young, you can see it. And the rest, you can see it from here. Thank you. And by names of Vida Subiza Anita. My name is
Okay, okay, okay. Thank you. Thank you very much. I understand the video wasn't clear for some parts. Okay, the video wasn't clear for some parts, but the one uploaded on YouTube is very clear and you can ably watch it. So, but for now, because we are listening in carefully, let's come to these questions now. Hope you can see the questions right now. The video, the link that you see under concepts is the one you have been watching. So you have some questions there to answer. Of course, the audio was very clear and she listed a number of requirements she needs. This is a student of senior 2 whom I tasked to record this video by using a phone. So going forward, let's hear from you the answers to those questions.
Okay, we
Maybe
have
you already
one.
read the questions already. So let's hear from you. Question 1. Yes, Tony.
Yes, teacher.
Are you able to answer for us question 1?
Yes.
Okay, go on.
Question one was asking for the requirements Anita used.
Okay.
So one was she used a spade, broom, and a wheelbarrow.
That's very good. As well in the chat, I see a number of answers coming up. That is very good. Okay, and then Mercy as well is talking about a sack. So provision, if you don't have a wheelbarrow, you can use a sack. And for the activities you're going to do, you see that we gave that as an alternative. Then question 2, anyone to give us answers to questions 2, or to question 2, sorry. Major physical quantities that relate with Anita's activities of cleaning the poultry house. You remember the physical quantities? We talked about this in senior 1. Anyone ready to share with us?
They can also put in the chat.
Yes, please revise the physical quantities. Someone should be able to share with us. And first of all, what are physical quantities, if you may ask?
Okay, anybody to give us the physical quantities used by Anita? Do we have anybody? Okay, Birunji, you saying something? Sharon, you can unmute there and then talk to us. Birunji, your microphone is not working. Your hand was up, but you couldn't talk to us. Anybody who can tell us the answer for question 2?
Or maybe they need a hint. Maybe they have forgotten. Okay, remember we defined physical quantities, and we talked about the fundamental or the basic quantities to begin with, and then the derived quantities. These were listed in senior 1. I think the first two lessons.
We have some, Christine is saying distance.
Okay, distance, that is very good.
Yes.
Because Anita was walking, okay? So distance is right. Any other?
And Mase, for her, she has given the standard unit. She has said liter in kilogram, birunji,
I
time.
think the quantity in that case would be mass, okay?
Yes.
Because the poultry the chicken droppings have some mass, then time is very good because you need to time yourself cleaning the poultry houses or any farmhouse. A force is right because you're pushing a wheelbarrow or you're lifting your sack. A speed is right because you're moving at a given speed, but this will be scalar, and then velocity can come in if you're dealing with a vector. Then length, of course, when you measure the distance from the poultry house to the pit, where she put the chicken droppings. Then temperature maybe of the room, because she said that you need to give it some time to cool down. That's good. Weight as well is right. Okay, thank you for all those answers. Let me hope you're listing them, because we shall request you to post all these answers in the WhatsApp groups. Now, there's this full video. For the interest of time, I won't go into that, but the link will be shared and you're able to watch this. But Teacher John showed to us how he can measure the mass or the masses that we use in laboratories, okay? And then determine the depth to which those masses will drop, okay? And if you know the mass, you know the acceleration due to gravity, which is a constant, and at all level we use 10 meters per second squared, and you know the distance through which it has dropped or the height, then you can determine work as you are going to see. Now, going forward to the next slide, someone to read for us what we have right there, but taking time because we need to internalize this. Let's have Simpson talk to us.
Definition for the work done. Okay, let me start.
Yes, go on.
Work done. The definition. This is the product of and distance moved in the direction of force. All work is done when the point of application of forces moves in the direction of force. Thus, the distance moved has to be in the direction of the applied force. Note 1. A force may be applied to move an object to the right, but instead the object moves to the left. The force in this case has not done any work. 2. The S1 unit of work is a joule. Are you able to define a joule? The formula: work done is equal to force times displacement. The S1 work done is equal to Fs. Note, if the body is projected vertically, the force acting is the weight of the body. Work done is equal to weight times displacement. Work done is equal to mass grams then S, where G is the acceleration due to the gravity. G is equal to 10 ms squared, meters per second.
Yes, acceleration due to gravity.
Okay, thank you, Doreen, for that. But
Okay.
I was
Teacher
still
Doreen, you
telling,
can go on. You can go on.
yes, I was still telling Doreen that that G, the good thing she has defined it, but it is not a gram, it is acceleration due to gravity.
Yes, yes, very right. And we are going to see that for the formula for weight, but we talked about this already when we dealt with pressure, you remember? We say that if you have your mass in kilograms, then to obtain weight, you multiply the mass times G, where G is acceleration due to gravity. And at O level, is given as a constant, and that is 10 meters per second squared. Okay, we have defined our work done as a product of force times distance moved in the direction of force. So that is very important to underline. The direction of a force is very important. And as we move forward, you see that if you're moving a certain distance in a specified direction, then you're talking about displacement, of which when you come to the formula work done, that's why you have multiplying the force times the displacement, which is S. And then we have a note, but basically I'll talk about two, the units for work done are joules, but of course when you come to energy, you see that both of these quantities have the same units. But as well, you should know that if you moved through a certain distance, maybe to your right, okay, and then you come back to that same point, okay, then you will have no work done. Why? Because you have moved a certain displacement, maybe to the positive of X, and then you have come back to the same position you were. And remember, displacement is a vector quantity, and the direction is very important in that case. Okay, and then the formula is very well right there. So if you're moving maybe along a horizontal surface, then you should know the force applied and then the displacement moved. But of course, if you're lifting maybe any object of a given mass from a certain point upwards, then you're dealing with weight, and then we should know the height through which that body has been lifted. And I've talked about the acceleration due to gravity, which is G. And for now, we need to move forward to the next slide. Now, remember we had the first activity where we watched the videos. Now, this activity is similar to what Anita did, okay? Though we shall task you to do this anytime. We said you can have any farmhouse that you're looking after, okay? You can be having a cow shed. You can have, someone should mute that mic. Someone's mic is open. Please remember to mute your mic. Okay, thank you. I was saying you can have any farmhouse that you're running or looking after. So at any one point, you should be able to carry out this activity. So for now, we might not go into it, but we shall have someone to read for us this activity. We understand it, but it is similar to Anita's, as I said earlier. But of course, we shall look at the question that we have right there. So anyone ready to read for us? You put up your hand. Let's have a gentleman this time. Don't we have a gentleman this time to read for us? Teacher Doreen, do you see anyone?
Yes, we have Tony. Tony is saving voice. Wanduru.
Yeah, Tony has been active this evening as well. Tony, please go on, take us through these activities, and then we shall have a lady to read for us the question.
Activity 2, teacher. Teacher?
Yes, yes, please. Go on.
Okay, we go on. Requirements. A spade, broom, hoe, wheelbarrow, or sacks. Tasks. Given that you are planning to clean your poultry house. Task 1. Look out for a spade, gumboots, a hoe, and a wheelbarrow or sacks. Task 2. Collect the chicken droppings from the poultry house into a heap. Task 3. Load it on your wheelbarrow or into sacks to a weight you can push or lift. Task 4. Push your wheelbarrow or lift your sacks with chicken droppings to the pit and offload the droppings. Caution: do not carry the chicken droppings right away to the garden, but rather first keep it in an open place or pit for some days. Thank you.
Okay, thank you, Tony. As I said, those are the tasks. Okay, those are the tasks you'll go through as you're cleaning any farmhouse that you're running right now. Of course, we don't have time to see your activities right now, but please take time to go through this. It will be very important for us because they are the similar tasks that I gave to Anita and she recorded the other video. Very important. Then we have a question right there. I don't know whether someone is able to explain why. Why do we first keep these droppings somewhere, maybe in a ditch or somewhere, a pit, for some time? Anyone with a view? Faith, I see your hand. Talk to us.
I forgot to lower my hand, sorry.
Okay. Ahan, talk to us.
Master, when they were there, they are a good source of manure.
Okay. They are good source of manure, but why do you first keep them? Why don't we just take them right away to the garden? Why do you think so?
To pass through.
Okay, that's good. So that can be your other homework. Okay, so take note. Now let's come to this question. Someone to read for us. Yes, please.
We have another one from Luku. He's saying that to break down the acidity of the droppings.
Okay.
Yes.
Okay, that's very good. That's very good. Okay, so for now you can research more about this, and then we shall pick your responses through the Padlet. Now, let's come to the question. It is only one, but let's see how we go about it. Depending on the formula we looked at, okay, earlier on, how can we calculate for the work done here? Okay, so someone is very fast, but you need to take us through. Someone is having the answer already. Shira, talk to us. How did you get the 4,000 joules? Shira, are you able to talk to us? Okay, any other person? We looked at the formula for determining work done. Anyone ready? Sheila, come on board. Come, okay. Ahan, talk to us. Talk to us. Talk to us.
Master, according to me, in the question, they have given us the force, which is 2,200 newtons, and the distance in centimeters. So what I did was, first of all, to change the distance into meters.
Okay.
So I got 20, and then I replaced in my formula. Work done equals to force times displacement, where I got 200 times 20 to get 4,000 joules.
Okay, okay. That's very good. That's very good. So when you divide by 100, you'll have 20 meters right here. But remember, we say that work done will basically be, we use abbreviations here, but you should write in full. As students, you should write in full. So B 200, and then times, I'll use a dot right here. Okay, or I can use the brackets to multiply with that, and this will give us 4,000 joules right away. Thank you very much, Ahan. All right, so right away we shall hope you have noted. This is very important for you, but of course I will move away from this. I'll move away from this very fast. Okay, we come to this example. Someone to read for us? Someone to read for us? Okay, we have a number of ones. Okay. Karen has been silent. And then we shall have Mercy maybe. Okay, Karen dropped. Mercy, talk to us.
Example, Derek uses 10 20-liter jerry cans of water to clean his cow shed. He carries them on his head from the water source to the cow shed. If he is 120 centimeters tall, calculate the work done by Derek to lift a jerry can full of water from a level ground to his head. If the weight of the empty jerry can is negligible, take density of water as 1,000 kilograms.
1,000? Mercy? Okay, the density of water is 1,000 kilograms per meter cubed. Okay, we talked about this as well when we dealt with pressure. Now, let's have someone to take us through this example. I want an interactive class. Anyone ready? You should be knowing that we want to determine the work done. Okay, need to calculate the work done by Eric. Okay, but you have a 20. Okay, he uses 10 20-liter jerry cans. By this time, we are focusing on to just lifting one, but it is full to capacity from maybe the ground to his head, but you are given the height. Mercy, do you want to take us through, or you just left your hand up? Okay, let's think through. Let's take 2 minutes to think through and we see what is possible. If you know the liters or a 20-liter jerry can, okay? You know the volume, but in liters, okay? You know the density of water. We are saying the jerry can, the weight of the jerry can is negligible. So what you'll be determining will be the weight of first the mass of water, and then after mass you can obtain weight. Then how do you proceed to obtaining work done?
We have some formula there in the chat.
Oh, I see Gloria is giving a formula for force. But remember, this time we are lifting. You remember the other formula? Let me maybe go back. Maybe I go back. Remember we said, if you're lifting from the ground vertically upwards, the weight, sorry, the force acting will be now weight, but you should as well know the height through which that object is displaced, okay? But when the body is moving either along an incline, we shall come to that, or maybe along a horizontal surface. If maybe you pushed a wheelbarrow with a horizontal force, as you saw Anita, okay? Then you'll be having force times the displacement. Okay, Maggie is giving a right answer, but this time it will be work done and not force. You're giving F, but that will be work done, where M is the mass in kilograms, G is the acceleration due to gravity, and then H is the vertical height. And for this case, we shall take the height of Derek. Okay, now briefly, I will summarize for you a few, but before, let me ask a question. What is the equivalence of a liter in centimeters cubed? Who can give us the answer to that? 1 liter is equivalent to what in centimeters cubed? Thank you, Chanel. That is right as well. But of course, let's first begin from obtaining volume. Let's do this very fast. We have only 10 minutes. We want to be on time. Okay. Let's be shift. We should be fast as students. Okay. 1 liter is equivalent to what? How many centimeters cubed? Volume in centimeters cubed of a liter. If you have forgotten, use the Google, okay? You should use all the sources around you to be updated. Search if you have forgotten, search. What do we have? What do you have? Okay, please don't just mute your mic. You need to first put up your hand if you want to say something. Anyone? If you can't speak up, you can use the chat. Is it 100, Mercy? 100? A liter in centimeters cubed? Okay, what of in meters cubed?
Mr. Pardon, the question.
Well, the question is, what is the equivalence of 1 liter in centimeters cubed? The equivalence of 1 liter in centimeters cubed.
1 million.
Really? Have you made enough research? Okay, what of in meters cubed? Someone to take us through. Meters cubed, what do you have? Want to have this done, and then we move forward. Okay, I see. Someone, 1 liter in meters cubed. Want that volume. Because if you know the volume in meters cubed, you can obtain mass because you have the density already. Okay, we talked about this in under pressure. Teacher Doreen, do you see any responses coming up?
Yes, we have it in the chat.
Okay, okay. Okay. Joan, are those centimeters or meters cubed? And then Mercy, include the units. Yeah. But of course, when you include units, the right ones, you'll be able to note that in meters cubed,
Master, I'm getting 0.01 cubic meter.
Okay. This will give us 0.001. Okay, I'll use that for the interest of time, but take this as a power, okay? Okay. And then if you want the volume, now you have 20 liter jerrycan. You have a 20 liter jerrycan, okay? You have a 20 liter jerrycan. What will be your volume? Someone. Volume is 20 liters, okay? So what will this be? Do you have any answers? In 20 liters in meters cubed, what do you get? Someone very fast.
Master, it is 0.02.
Yes. If you multiply very well, you see that you're getting 0.02. Yes, and then I use that is a power for now. I use that, but you should be able to observe very well. Okay, now after knowing the volume and you have density, how do you obtain the mass? Because if you know the mass, you can obtain weight, and then you know the distance already. Someone to take us through. How can you obtain mass if you have the volume and then we know the density? Someone to speak up. What will be our mass, the formula for mass? If you know the density and then volume. As students, we should make research, research. Okay, Sharon, talk to us. Okay, Karen, talk to us.
If we have density and volume, I think it would be density times volume.
Density times?
Volume.
Yes, times volume. Okay, but we know the density already as 1,000. Remember, we are saying the weight of the jerrycan is negligible. Okay, and then we shall multiply it with this, which is our volume. Okay, and what do you get? What do you get? Very fast. Use your calculator very fast. We have only 2 minutes. Someone, yes, Mildred, talk to us.
I've actually got 20.
Yes, you get 20 kilograms. Now, if you know the mass, how do you obtain the weight? Oh, sorry about that. How do you obtain the weight if you know the mass? If you know the mass and then the acceleration due to gravity, how do you obtain weight? Very fast. Weight will be equaling to, yes, mg. Someone is giving the answer in the chat. Yes, mass times g, where g is acceleration due to gravity. Now substitute 20 g, okay, and then times the acceleration due to gravity, which is 10. It is a constant at all level, and this will give us someone very fast. Yes, 200, but these are newtons. Okay, so after getting your weight, then you can obtain the work done. Okay, obtain work done, and our work done will be what? Someone to speak up very fast. Work done will equal to, someone talked about it. Talk to us. Please unmute and talk to us.
Our plan shall be equal to those 2,000 newtons times 10, giving us 200 newtons times 10.
All the weight. Okay, weight times the height. Okay, and this will give us the 200. But remember, we have the distance, but in centimeters. Okay, from the in centimeters. So our distance would be what? We have the height of Derek, because it's lifting from the surface to the head. That is having the centimeters. So in meters, what will be his height?
1.2 meters.
1.2 meters. Yes. Now we come to this work done. Okay. And then this will be, okay, I use the brackets here. And this will give us what? Someone to give us the answer. 200 times 1.25, sorry, 1.2. What do you get? Yes, you get 240 joules. That is very important. Okay. Okay, you record that. Okay, so that is the answer we have for that example. So you should take note. Let's have only 2 minutes as our extension or added time. And then we shall look at now the examples, sorry, the questions that you will do. And then we shall be done here. But please remember to register. We shared the registration link already in the chat. But also the Padlet, Teacher Doreen, let me share the hand-in Padlet where the students will share their work. I'm sharing the link for registration, but for the Padlet as well will be shared. Now, I would love to move away from here. As we said, we should be first students. So you should take a screenshot of this very first, and then we move. Okay. Now, going forward to that as our exercise. Okay. So those are the questions that you will do this evening, and then you will post your work in the Padlet as you have been doing. Okay. Right. My battery is okay. The good thing we are ending this. So those are questions. You can take a screenshot of that, or of course you are posting this work in the Padlet. You are post this work in the Padlet. Okay, Teacher Doreen, you can be talking about or reminding.
Yes, Teacher Joseph.
Okay, Teacher Doreen, you can be talking to them about the registration as I get some battery here.
You go in during this farm camp period. The registration link is already shared by within the chat of that session. So make sure you register. And also those ones who haven't registered, also for the farm camp, you make sure you do register yourself. But if you registered already, it is not important for you to register again. So it is better you register once and for all. So you make sure.
Okay, thank you, Teacher Doreen. I think they have done the needful, so we can move to the task that they have. Okay, that is a task. Basically, you need to post your work in the Padlet. The link is attached right there. But of course, we shared it in the chat already. So please take note. And then from that, I will have this as our end. And we thank you for everything. We thank you for your attendance. I thank the teachers who have been on board and all of you students for attending this and for the time. Please take time to do that work and then post in the Padlet. We shall have a few questions and then we shall end this. Ahan, I see your hand is up. Talk to us. If you have any questions, please put up your hand.
Master,
okay,
I did
go
not
on.
get the questions.
Pardon? Oh, questions?
Yes.
Okay, there are the questions. Hope you can see them now.
Yes, thank you, sir.
All right. Any other questions? Shakila, talk to us.
Is the
Shakila, your network is poor. I can't pick your question. Maybe you can type in the chat. Teacher Doreen or Teacher John, do you see any questions in the chat?
Uncle Julius.
Okay, I think we don't have any other questions coming up. I don't see any. Shakira, are you typing? Oh, it is okay. Okay, many people are thanking us. Thank you as well for attending. We are still going on with the farm camp, and tomorrow we have the closing function or the final functions. So please be part of that as well. WhatsApp links, Teacher Doreen. Okay, let me see whether I can have one that is not full. Okay, I have one here. I have one here. Let me pick it very first. WhatsApp link, that is senior 3. Okay. If you haven't, or if you're not in any of the WhatsApp groups, please take time and join. But the older students don't join if you're in one. Someone is asking for the registration link. It is right there, posted as well. Any other? Okay. Yes, we are going to send this document to the WhatsApp groups. No worries, Shakira. Okay, registration link, I have shared it. Okay, Padlet, okay. Oh, okay, and in Padlet is right there. Shakira, right there. Okay, any other? Okay, I don't see any other. Okay, we thank you very much for attending. We thank the teachers who have been on board as co-hosts and those who have been in the background. We ask you to continue attending our sessions. We shall resume our normal program next week. So please look out for any updates in the WhatsApp groups. But I thank you all and I wish you a blessed evening.